Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 136, Problems 5 and 6. For problem number 5, we have a geometric figure here, such that each triangle, this is made of 4 congruent triangles, and each triangle has legs square root of 7 plus 1 and square root of 7 minus 1. What is the number of centimeters in the perimeter of the pinwheel? So, first of all, notice that we can split this problem into 4 equal subsections. And it's this plus this. And each of these can be split into 2 subproblems, which is finding this length and finding this length. In our case, we'll find AB and we'll find BC. By the Pythagorean theorem, AB is equal to this expression, which is equal to 4. In other words, this is equal to 4 here. Now, BC is equal to BO minus CO. But CO is just the short leg of another triangle. Therefore, we see that BC is equal to BO minus AO, which is equal to 2. Finally, we add these up and divide and multiply by 4 to get our desired perimeter of 24, which is option choice B. Now for problem number 6. There are 10 people sitting around at a table. And how many ways can we arrange for each person to shake hands with another person at the table such that no 2 handshakes cross? So, for instance, in this problem, we could have someone shake like this, someone shake like this, another person shakes like this. Yeah, this is a very special example, but from here we could also go like this and this. But anyways, you get the point. So first, note that each handshake basically creates us 2 smaller versions of the same problem. So, for instance, if we handshake like this, we get this problem here, and we get this problem here. Now, these two subproblems, they don't interact. Because if they did interact, for instance, if this guy decided to shake hands with this guy, then we would cross this thing, and this is not allowed. So, with that, we can see that we can use, recursion. So recursion is the idea of splitting down into smaller subproblems. And by splitting into these smaller subproblems, we can slowly build our way up to the final answer. So, let AN be the number of ways for n pairs of people to shake hands such that no handshakes cross. In our case, there are 10 people, so there's 5 pairs of people, so we wish to find a sub 5. Now, notice that a sub 1 is 1 and a sub 2 is 2. That's because there's only one way to have one pair of people to shake hands, like that. And there's 2 ways for 4 people or 2 pairs to shake hands. That's 1, 2. That's 1 and that's 2. So 2 ways. Also, we find our so-called something like along the lines of a recursive identity. So, in this case, a sub k is equal to a sub k minus 1 plus a sub k minus 2 times a sub 1 plus a sub k minus 3 times a sub 2, etc. to all the way to a sub k minus 1. Now, to see why this is true, we're not going to prove it rigorously here, but imagine that you have like a bunch of points. And where there's so many points that I'm not going to draw them all. But, starting from here, you can draw to any one of these, but you can only draw to half of them actually, because if you draw like this, then you get an odd number of points here and an odd number of points here, which is not allowed. Both of these are forbidden. So, we can only draw them to here, to here, to here, etc. Now, for the first case, there are, so let's say there's k pairs of points in this diagram. If we draw one here, then we have k minus 1 pairs remaining because we only have 2k minus 2 points remaining. So that just becomes a sub k minus 1. Oops. That just becomes this. Now, hang on. Technical issues here. Okay. Okay, finally. But anyways, now if we draw a line from here to there, we see that we can either we have one pair here, and only k minus 2 pairs remaining in this area, which corresponds to this. And now if we erase everything, yes, it worked this time. Good. Boop. Then we have this, which has 2 pairs here and k minus 3 pairs here, which is this. And we can continue so on in this way until we get all the way to here, which corresponds to this, by the same argument as this one. Therefore, this identity holds. So we can now use this identity to get the remaining entries. In this case, a sub 3, a sub 4, and a sub 5 to be 2 plus 1 plus 2 equals 5. 5 plus 2 plus 2 plus 5 equals 14. And 14 plus, I believe it's 5 times 1 plus 2 squared, which is 4, and then another 5 times 1, or 5, or sorry, or another 5 times 1, which is another 5, and then another 14, which totals out to 42. So the answer is D. Now, you may have noticed that these numbers follow a specific sequence, which is 1, 2, 5, 14, 42, etc. And if you go to the online encyclopedia of integer sequences, OEIS, just search this online, you'll see that this actually is the Catalan numbers. Now, the Catalan numbers show up in a lot of places in combinatorics and have the formula 2 choose n over n, something like, I don't exactly remember, but just search it up online and you'll get lots of related questions that also have the same answer. Thank you for watching.